Today we are talking about your unit circle, okay? The unit circle has similar properties in the 6 trig ratios as it does of a right triangle, okay? The one main difference about a unit circle compared to, say, an ordered pair or like a point or a right triangle is that your radius of a unit circle is always 1, which means the hypotenuse of any triangle that you draw in the unit circle is always 1. Because the radius is always 1, that means that the sine of your angle, okay, the sine of t in this case is going to represent our angle, t, theta, x, alpha, gamma, doesn't matter what the angle is, we're still talking about an angle here, so it doesn't matter what letter it is, but the sine of that angle is still your opposite side over your hypotenuse. Like if I were to create a triangle right here, right, t would be inside your angle. Your opposite side would be this vertical distance, this y length, right? It would be opposite y over your hypotenuse, which is what? 1. Well, y over 1 is just y.
Why is your hypotenuse 1?
Because you're in your unit circle. In your unit circle, the radius is always 1, which means the hypotenuse of any triangle that you draw, if it's on the unit circle, it's always going to be 1 no matter what. No matter what. Your cosine is your adjacent side, which is some x length over your hypotenuse. X over 1 is just x. Tangent is still your opposite side over your hypotenuse. Well, it's your y value over your x value, y over x. Okay? The same thing that it was before when you were doing ordered pairs. Same thing. Secant is the reciprocal of sine. Everybody knows what I mean when I say reciprocal. What is it? You flip it. So instead of being y, it's going to be 1 over y. Secant goes with cosine. It's 1 over cosine, 1 over x. Cotangent is the flip of tangent, x over y. Okay, it's the same 6. They have not changed. Okay? Because your unit circle is a special type of trigonometric thing in its own. Your x coordinate, whatever point this is, the x value is always cosine, the y value is always sine. So if it asks you for the sine of a particular angle and it's in your unit circle, they want the y coordinate. If they ask you for the cosine of a particular angle and it's on your unit circle, they want the x value. If they ask you for the tangent and the value is on your unit circle, what are you going to do? Y over x, tangent, y over x, yes. It is just that. It is the same thing you wrote down when we were talking about ordered pairs. It's basically toe-to-toe, right triangle. That's it. It's just dealing with different things, but they're all essentially saying the same thing. It just depends on what you're in. Okay? So, this is really and truly your unit circle. Everybody has a green sheet of paper, yeah?
Right.
Okay. If you need to trim it up, you can. You know what the scissors are. Just make sure that you do so maybe in a better time, would not be now. Okay? The unit circle is comprised of, question? Yes, this is the last thing on this page. The unit circle is comprised of degrees, radians, and ordered pairs. As you can see, there's a line that has a little small circle that represents degrees. There's a line with no circle that represents radians, and then there's parentheses and commas, which represent an ordered pair. Now, the way that I've taught unit circle in the past has been somewhat successful, so I'm going to continue it. There's a pattern with the unit circle, okay? And the pattern is all about the first quadrant. So you're about to receive a paper that has the degrees, not the radians, not the ordered pairs, but we'll build that in just a second, of your unit circle. This will probably go on page 70, 75. And I doubt I'll be able to squeeze into 73. Okay? So we're going to look at the very first quadrant. 0 clearly starts right here. We know this. That's where our initial side is located. That's where everything is always based off of. The next little segment, if you were to take a protractor to this unit circle to any unit circle, this would show 30, this would show 30 degrees. Okay? The next one would show 45 degrees. The next one after that would show 60. And the last one at the very top, even if you didn't have a protractor, you would know this would be 90 degrees. Okay? Now, every degree has a radian counterpart. 0 degrees is how many radians? No. 0 degrees is how many radians? Not a trick question, I promise. It's 0. 0 pi radians. Do you have to include the pi? No. Okay? 0 degrees is 0 pi radians. 30 degrees is how many radians? How do you convert degrees to radians? Pi over 180. So let's do this. 30 times pi over 180. Doesn't 30 go into 180? 6 times. So this is pi over 6. This is the radian that goes along with 30 degrees, no matter what. Everyone be on this side with me, okay? We'll go back to the big one in just a second. Stay on this one with me for a second. Okay? 45 degrees. Convert that to a radian. Is what? Pi over 4. So 45 is pi over 4. The next one would be pi over 2. This one is pi over 3. You still can do the same type of conversion. And the last one, 90 degrees. Pi over 2. Now, today, yes, if you need to use the conversion of pi over 180 to figure out what degree matches up or what radian, that's fine. After today, that leniency is going to decrease up to the point where I'm going to expect you to know that when I say 30 degrees, you're going to be able to tell me right back, no hesitation, pi over 6. Same thing with 90 degrees, you're going to know automatically that's pi over 2. And then when I say 300 degrees, you're going to be able to tell me
3 pi over 7.
But we're going to get to that point because there are certain angles that are on your unit circle that have their corresponding radians, and you are going to need to know these. Okay? You are going to need to know these. So, the ordered pairs. Oh, I didn't do that. What has this unit been about? So this is what I'm going to do. I'm going to create a triangle with each one of these, okay? If you're using pen right now, just be careful. Now, I am going to do all my triangles in this one, so let's try to make it nice and organized if you are planning to do the same notes that I'm doing. I'm going to create a triangle with that 30-degree angle. Get it right there. We'll drop down a perpendicular to my x-axis like I've been doing this entire time since we started talking about triangles and ordered pairs and things like that. Okay? So this right here is 30 degrees. And if this is 90 degrees, what's this angle up here? 60. This is a 30, 60, 90 degree triangle. At the very beginning of this unit, I said that you're going to see this again. You really, really are. Now, because we're in the unit circle, we already know what the hypotenuse is of this right triangle. What is it?
1.
It's 1. Okay? But now the question becomes, what is this length down here? And then what's this vertical length? Okay? Because that's going to represent the cosine and sine of this 30-degree angle. Now let's see who took their notes. Do you remember your reference page? I think it was on page 61. Can you flip back to that? This is a 30, 60, 90 degree triangle. And remember, I gave you like a little cutout reference to help you with that. In a 30, 60, 90 degree triangle, looking at that page, What was the side across from the 30 label?
Short legs.
True. It was labeled X. What was across from the 90-degree angle? 2x. Talking about the reference. And then across from the 60. Square root of 3x. Okay. Now, my question to you is this. This applies to this triangle over here. The one on my triangle matches up to what in this triangle? 2x. So that means that 1 has to equal 2x. Well, if 1 has to equal 2x, what is x then? 1 half. So x, the side across from the 30 degrees, is 1 half. See that? Or did I go over you guys' heads? So the side across from the 30 degrees is 1 half. So x is 1 half. Then what's the side across from the 60 degrees? Square root of 3 over 2. Because all you do is plug in the 1 half and multiply. So what's my x coordinate for 30 degrees? What is that? What's my x coordinate? How far over did I go to get to 30 degrees? And how far up did I go to get 30 degrees? And there's the ordered pair for 30 degrees. There is a pattern.
That goes on here, right?
We'll worry about that in just a second. We're going to do this part first. Does everybody see that? Yes.
So that's your cosine and your...
Exactly. And remember, cosine is x, sine is y. So when I ask you what's the curve sine, what's the cosine of 30 degrees, you're going to say, because it's the x coordinate of 30 degrees. And if I ask you what's the sine of 30 degrees, you're going to tell me 1 half. Tangent, you have to do y over x. Do a little bit of math, but you'll get your answer. Question on 30 degrees. Yes? Exactly. They're all positive because we're in quadrant 1. Let's look at 45 degrees. I'm going to draw another triangle. I'm going to use a different Yes? Why am I plugging 1 half? Okay. Because remember, the makeup of the general 30, 60, 90-degree triangle is x, x root 3, and 2x. Since the hypotenuse is 1, that equals 2x. Like, these two have to be the same value. So we set up that equation 1 equals 2x. And we solved to figure out that the x side was 1 half. All right, let's do 45. I need to figure out the same thing. What is that ordered pair? Okay? But the beauty about 45 is that if this is 45 and this is 90, what's this angle up here?
45.
So this is what type of a triangle?
45. Yeah.
Isosceles. Hypotenuse is still 1. What was the makeup of a 45, 90-degree triangle?
Same on the side. The hypotenuse of 2 is square root of 2.
So using the same type of pattern that I used before, 1 equals what?
1. 2.
Solve for x. Because if I can figure out what x is, those are going to be my 2 legs in my triangle. 1 over the square root of 2. But I can't leave it like that. And those are the x values. That's this length right here, square root of 2 over 2. And that's this length here, square root of 2 over 2. Which means my ordered pair is using this general makeup triangle.
Oh, okay.
And we set 1 equal to the square root of 2x. Solve for x. We still okay? Last one, 60. Well, not really last one because we still got to go back and do 0 and 90, but those are easy. Yep. Close. Here we go. 60.
Oh, it's a 30. 69.
I know this is a lot right in here. That's why I'm trying to use different colors here, but 60 and 30. My hypotenuse is still 1. This is the same type of triangle that the red one was, except what's this length down here?
One half.
This is the 1/2. And then the y
Square root of 3 over 2.
is the exact same 30, 60, 90-degree triangle. It's just flipped. And to be honest, a lot of students do get these two confused, 30 and 60. But this is what I usually do. You see when I drop down that perpendicular, it hits halfway on the x-axis. So x has to be 1/2 because it's halfway on the x-axis. Same thing with the kind of the opposite with 30 degrees. If I drew a horizontal line over, it hits the y-axis halfway. So y has to be 1/2 for it. Genius. That's how I had to use to help me remember the unit circle. My teacher made us do it in a minute.
So what?
All right. Now 0 and 90. Those are the easiest ones. Close. 90 degrees is 0, 1 because it is a radius. There's no, you don't go anywhere on your x-axis, but you do go up 1 unit. But 0 is 1, 0 because you went over 1 whole unit, but you didn't go up anywhere.
How is it possible the radius is always 1 if there's a curve? If it's in the center of like the corner plane?
Well, see, the thing is that the highest, no matter what part you are on this curved part of the circle, the distance from the center to that is always going to be less than 1. And there you go. That is the first quadrant of your unit circle. And the reason why I like to spend so much time on the first quadrant is because it is a pattern. The unit circle is a pattern, all based off the first quadrant. So if you know the first quadrant, you know the rest of your unit circle. So we're going to go back to this. I got my degrees. I'm going to fill in my radians next. I'm going to use purple for my radians. Oh, I already have. So that was 0 radians, pi over 6, pi over, and pi over this one, pi over 2. I use the lines as the fraction bar. You don't have to write it above. That's just how I do it. It's going to be impossible for me to try to write as big as I do in that little space. And then lastly, the ordered pairs. This one is 1, 0. What's 30 degrees? Square root of 3 over 2. 1/2. 45. 60. And then 90. 0, 1. And like I said, everything is a pattern. So this process does continue forward. Okay? I'm going to do my ordered pairs first because that's where the pattern comes in. Okay, really and truly. Let's hit all the quadrantal angles. Okay? Over here. What do you think this ordered pair is going to be? I think I heard collectively 0, but what's this one? Because you're in the negative x-axis. You're 1 unit over on your unit circle. What about this one down here? 0, -1. Because you've gone down 1 unit. Think of the quadrantal angles. They are x and y. They are essentially x and y. Now, 30 degrees matches up with this angle straight across from it. Okay? if I did a really quick triangle, don't draw this. If I did a quick triangle, isn't this 30 degrees away from the x-axis? Making this 90, making this 60. My hypotenuse is still 1. What's the side across from my 30?
It'd be 1/2.
It'd be 1/2. And the side across from my 60? Because you are in the second quadrant. There's your ordered pair. It's the exact same thing as 30. It's just x is negative because you're in the second quadrant. See that? I'm erasing this triangle. I was just doing that for the visual. That is the only difference. It's the same ordered pairs all the way around. It's just depending on what quadrant you're in, whether it's going to be positive or negative. This one over here matches up with 45. Negative square root 2 over 2 and positive. And then this one at the top matches up with the 60. You see why I said knowing the first quadrant is so important? Because honestly, you flip it over and those are the ordered pairs. Exactly. Quadrant 3, both of them are what? Negative. Okay? Now, the one that goes along with 60 in this angle over here, they make a box. Or if you want to say, hey, they're on the same line, just straight across from each other. You see? Are you with me?
Yes.
So what's this order pair?
-1/2 and negative square root over 2. Both negative.
Swing this one. What's this?
They're both negative.
I mean, it does also, I can create if I wanted to, like a little box where they all go together. And the one at the top that's really close to the x-axis, what's that one? Negative.
I have a question. Isn't it just like the last one they did on the one before it comes just from that?
And the last one. Y is negative, x is
Positive.
positive. What's this one?
1/2.
Half, and then
Square root over 2.
the one in the middle? The ones in the middle are always that. Okay? And this one up here?
Square root of 3 over 2.
Negative half. Let me fix this because this should have been a red color. They're supposed to go together. For the visual sake of things. Okay? They're your ordered pairs. The degrees and the radians. There's a pattern with your radians too. With your degrees. 60 is how many away from 90?
30.
So then this has to be 30 away as well.
120.
120. How far is 45 away from 90?
45.
So how far is this one from 90? How far is this away from 90?
60.
So what's 90 plus 60? What's this one? 180. You see how the unit circles coming together?
If you know the whole top half.
Yep.
If you know the first quadrant,
If you know the first quadrant, you know everything. That's why I spent that time on the first quadrant there. Okay? And to be honest, to go straight across here, just add 180 to the angle across from it because it's half the circle. What's 180 plus 30? 210. What's 45 plus 180?
225.
And 60 plus 180?
244.
180 and 90? 120 and 180. Am I going too fast? 180 and 135. And 180 and 150. And a lot of students forget this last one. It is a complete circle. So what's the last degree? 360. My pen is not right too big, so I can't squeeze it, but you guys can. And now the radians. So we're recording that. 120. You can sit there and you can convert every single one of these degrees. Okay? But if I give you a unit circle quiz and I say that you have 5 minutes to get it done, I don't think you'll be able to do it that fast. Okay? So, there is a pattern. What pattern I'm not going to tell you what pattern, okay? Different strokes for different folks. Okay? It really and truly is. Alright? If you can see a pattern, once I start filling these in, then by all means, that's your pattern. If your friend's struggling to remember the radians and you want to tell them your pattern, by all means, go ahead. I want to know your pattern is Annie simple. My pattern might not work for you. Okay? That's why I'm not telling you. Alright? I want you to figure out your own pattern. But if I convert, this is 2 pi over 3, 3 pi over 4, and 5 pi over 6. What's 180 as a radian? Pi. This one is 7 pi over 6, 5 pi over 4, and 4 pi over 3. I'm going as slow as I'm going. Anybody know what 270 is as a radian? 3 pi over 2. So we're going 1.5 quarters. So 1.5. 300 is 5 pi over 3. 315 is 7 pi over 4. And 330 is 11 pi over 6. 360 is 2 pi. And there is the unit circle in all of its glory.